When we talk about a locus, first we need to know and understand what does the term locus mean. So here's our definition up here. A locus is a point that moves around a number plane. It can move anywhere it likes as long as it conforms to a particular rule. What I like to think about is just a point. It can exist anywhere on the number plane. So if you've got a number plane sitting there, like your point can be anywhere. It can be any point. Generally we call it P, we can call it any letter. But imagine this little point P. P can move anywhere it likes. Okay, so it's roaming around, it can move around, it can have fun out there, but it has to conform to some rule. So locus can also be described here as a set of points. So P is that set of points because it can be multiple points there, and it satisfies some given condition. And that's the rule there. So it has to follow some rule. So we can have our locus in two ways. Firstly, we can have it geometrically. And when we talk about geometrically, basically we're talking about its graph. So we can draw the graph on the number plane, and that would be the locus there. Or we can get it analytically, which means we get an equation. So some algebraic equation that would describe the locus. Generally, this is the way we're going to do that, but they go hand in hand because we can get our equation, and then we can draw it up according to whatever we've got. So really, the only two pieces of mathematics we need to know to find locus questions is the gradient formula, which you've used before. M is equal to y2 minus y1 over x2 minus x1, the change in our y values over the change in our x values, and the distance formula, which derived from Pythagoras' theorem. That's the two pieces of mathematics we're going to use to solve all these questions. What we're going to have to do is it requires us to manipulate our algebraic expressions to get required form, but they're the two things we're going to find. Generally, in the 2-unit course, the locus rules we have and the equations we find will give us either straight lines, parabolas, or circles. In the extension 2 course, you can go on and start to find equations that will give us ellipses or rectangular hyperbola or hyperbola itself, but only in the 2-unit course we're going to do lines, circles, and parabolas. So let's have a look at this first one. Generally, the equations we've got, the questions we get, are a little bit wordy, so you've got to read them really carefully. The first question says A and B are those points, minus 1, 0 and 5, 2. So they sit there and they don't move. A and B are two particular points. What we want to do is show the equation of the locus of the point Px. So there's our point P, and it moves anywhere, but the rule that it has here is that P's got to be equidistant from A and B. So it's got to be the same distance from A as it is from B. So you've got your 2 points sitting there. Minus 1, 0 is there. So there's A. And 5, 2 is B there. And as long as you get the points that are equidistant, so the same distance at every stage, then the rule works. So what we're basically saying, if we're going to want to use the distance formula here, we're going to say PA is equal to PB, because the distance of P from A is got to be the same distance from P to B. Now, I've applied the distance formula. What I have left off, I've taken off the square roots. Both of them had the square roots there, but we multiply through and we can get rid of the square roots because they're on both sides. So it just leaves us with the application of the distance formula on both those sides. What we do then is, like, we can't do much to clean it up here except expand it out. I'd rather, if I could factorise, I'd factorise. That would be my first step. But what I need to do is just expand it out first. Now, I expand this side out, gives me the x squared plus 2x plus 1 and y squared. This side would give us x squared minus 10x plus 25 plus y squared minus 4y plus 4. So there's our expansion of those. Now I start to collect any like terms and cancel them out. 10x comes across, gives us 12x. We also get the y squareds cancelling out. 25 plus 4 comes across with the, well, we're taking the 1 across that side, and we took the minus 4y across that side. Divide everything by 4 because it's got a common number there, and then we can get down to the 3x plus y equals 7, which is an equation of a straight line. So any point that moves, such as equidistant from two particular points, will give us a straight line. That straight line, if we work it out, is actually its perpendicular bisector as well.